Thank you, and thank you all for coming along this morning, today. As the slide says, I'm Steve Cockerell, the Industry Marketing Director for Bentley, and what that really means is I'm interested in talking to you about the whole solution, from conceptual design through detailed design and construction, and then onwards into operations and maintenance, and really trying to get excited about the different tools that we can help you with to create the inspiring projects you're all working on. I'm also aware that I'm the presentation between you and a break and some coffee and something to eat. So hopefully I'll keep it light and interesting. And if you've got any questions, then I'm more than happy to take those at the end or during the break. We're going to reuse this slide to begin with, and Stefan actually referenced that as an industry, our scorecard is not a great one. We're not doing the best that we can in terms of digitalization. And this was a report published by McKinsey and Company in the middle of last year that looked into the why. Where are we focusing our time and where are we failing, and providing some ideas and some direction onto how we might do better. It found that there were three key areas where companies were focusing their times and effort. The first one was on digital collaboration, and we're all here to talk about BIM and collaboration and working together and making the most of technology to help us do that. The second was on back office integration, and I wondered about the topic or the title of this series of events, BIM and Beyond, and I think perhaps that points to the beyond, using the world of big data, the Internet of Things, and other information that's at your hands to be able to improve outcomes and give you more insight into the projects you're working on. And then the last one is on on-site execution, looking at how we can automate that process and move towards digital construction and almost a continuous life cycle where engineers are providing the direction but actually making technology and equipment work for us. Now, it came up with some ideas on how we can improve. Some steps that we might take. And in the interest of time, I'm not going to give examples of users that we have around the world doing just this. And I'm going to use one project right at the end, but I will just take some time to just step through each, because the first one is creating a digital strategy and an organization to support it. All I'd say there is that nothing ever happens by accident. Have a plan. Set milestones and maybe timescales for achieving those and working towards them. Ways in which you can make those steps forward is to try things, turn projects into test labs, celebrate the things that go well, but learn perhaps from the things that aren't optimal, and change the ideas and reapply them and try again, and just celebrate that success as you move forward and measure against them. I think the really important thing about BIM is information or data. I think it's our most valuable asset. Forget the software or the hardware. Data is the really important asset that we all work with. So let it lead the way. Let it do the work for you. And then finally, this is a really easy one from a guy representing a software vendor to say, increase investment in technology. Really what that's about is commit to it, and if it's not just with one organization, partner with different organizations to achieve the outcomes, achieve the vision that you have for going digital by working together. And what I wanted to do was play a short video to you about one organization in Malaysia that has done all of these 4 steps and is enjoying the benefits of doing that. And it's MRTC Corporation in Malaysia. Now, we're talking about BIM, we're talking about workflows, and they had a vision of actually handing all that digital information created during design and construction over into operations and using that as the basis of their asset performance and asset management strategy into the future. So let me just play this video. It talks about the importance of managing information well.
For us, the whole project life cycle is important.
It's a little bit quiet.
For us, the whole project life cycle is important, be it from the design, construction.
My sound man's gone from over there, so I'll play the video so that you can at least see the pictures of the project. But basically what we're talking about, and what he's talking about, is the challenges that they had on this second of 3 lines that are being planned in the Kuala Lumpur area of Malaysia. They came across a lot of different challenges with managing all of the different relationships between the people, the disciplines, and all the data that needed to be exchanged amongst all of the different stakeholders. And on this second of 3 projects, they look to put things right by using what we call a connected data environment, and that's where I'm going to go on to next, because that connected data environment, or CDE, I think is another reference to the beyond. We're moving beyond the common data environment to a connected data environment. So it's important to understand what that means. At Bentley, we talk about digital context, and that can mean many things, from the reality models that you've seen to traditional survey information, anything that provides context to the job that you're doing at that particular time. Digital components, and that can be many different things. I work in the rail area for Bentley Systems, and we're working with Siemens, for example. And so components to them might mean the different catenary components, the overhead line engineering components and structures and wire. But it's the components or the objects that are actually created and built and become your assets in the future. And then the all-important workflows. And we saw right from the very first presentation this morning, those BIM workflows, including PAS 1192. And after the break, you'll hear from my colleague Ian Miskimin. And that's really at the core of our work with the Crossrail Academy, and a lot of the reasons for why that has been such a successful exercise. Because the CDE goes not just through design and construction, it covers the whole life cycle. And we're creating both a project digital twin, a project digital version, and a performance digital twin. One that we can gain insight into using iModels throughout the process, gain insight to enable better decisions during the design process, or indeed on how to more reliably or more effectively manage your assets as an owner and operator. And as Stefan spoke before about ProjectWise on the collaboration side as well. So for the main part of my presentation, for this last half an hour, I'm going to spend about 15 minutes each on both road and railways, and give you an idea of our current solution, both for the 2 industries that I work within. But I'm going to kick it off with roads. And hopefully you will have heard of Open Roads. It's the successor to a number of products that Bentley had in the civil design space. And it goes and takes us through predominantly design and build, but thinking of the future into operations, which is where I'm going to start using some AssetWise tools. Now, AssetWise, as the name suggests, is helping you get wise on how your assets are working, how they're deteriorating in condition perhaps, and how you can change the decisions to improve the outcomes. So here we're looking at an existing road network, and we're using our AssetWise linear referencing system to be able to say we're going to actually look to put an upgraded road between these 2 major roadways, we can actually assign various attributes to them that become part of the information that we will manage. But the key reason for me to show you this video is Stefan showed you the huge model of Paris that have been created from that contextual information, from the digital photographs. We can use it in inspection as well. We can use it in operations. And here, the guy in the field or the girl in the field is taking pictures with their mobile phone, and then we can send those up to context capture. You can see it's only a few pictures. And up in the cloud, we create a reality mesh. We create a 3D model that we can then move around, we can view, we can measure, we can interrogate, and importantly, we can store as a record of the condition at that point in time against our asset database. Now, that information can be used to perhaps do remedial works on the bridge, or perhaps it's a reason for a bridge upgrade, perhaps. But you're using that information during an operational part of the life cycle to aid your decisions in design and construction, which is where I'm going next. So in design, we have a number of products under the Open Roads banner. We have conceptual design with Open Roads Concept Station, GINT, geotechnical solution, and earlier this summer, Bentley acquired another two companies in the subsurface area of the market, and that's two companies called Plaxis and Vision. So they're companies that you may have heard of, and that really does strengthen our subsurface capabilities. And then Designer and Open Bridge Modeler for our highways and our bridge design, before looking at visualization, and as Stefan showed, Navigator for BIM review. ProjectWise is always there as part of our CDE to help with design integration. But just a short example of a context capture reality model. You can see how Concept Station here allows you to draw in your proposed roads. We're changing here an earthworks length of roadway into a bridge section. It's very interactive, very easy to use. We can actually go in and change the design in any way that we want to. Here we're seeing how a link road is designed between those. A ramp is designed between the two roads there. Or indeed, we can design roundabouts in there. Hopefully you'll see how interactive and how quick and easy it is to start planning your scheme, planning your projects. Now, importantly, at any point in the process, you can click on a button and find out the financial implication of all those decisions you're making. So you can create some really inspiring designs, you can integrate all of the different disciplines, and you can find out, as it shows right about now, the financial impact of all those decisions that you're making at the earliest possible point in time. Now, CCC First Highway Engineering in China is a project I wanted to highlight to you because they had some really quite serious challenges. They needed to model over 3,500 subsurface utilities. They had 8 major interchanges to design in just 9 short months. And they used Open Roads Concept Station and Designer to do just that. And this little video here just shows how the clash detection, or more importantly, the clash resolution tools within Designer and Navigator help them move this underground ducting away from all of the different foundations for the new road. And that's really what I mean about improving design decisions. Imagine finding that there's a clash between those two different disciplines out in the field, and how much money it would cost to put a problem like that right. That might be a bit of an extreme example, but it's about solving those problems as early in the process as possible. And CCC First Highway have improved the 3D collaborative workflow. They've taken out a whole lot of rework that they had and experienced on previous projects, and optimized the sharing of information across all of their different disciplines and departments, with some quite significant money savings as well. Now, one of the other things I mentioned there was visualization. And I think visualization is about communicating. They say a picture paints 1,000 words. And out of Open Road's designer and concept station, we can leverage a piece of software called LumenRT to create some really lifelike renditions and visualizations and simulations of our projects. And here you see that we can also move into simulation environment. We can leverage VR and augmented reality directly from the engineering models to be able to immerse yourself in the design, or immerse your customers or members of the public in your design to communicate and convince them of the value of the projects or the infrastructure that you're designing, building, or operating. So really changing the game, if you like, in the way that we can show our engineering designs now, your engineering designs now. Now, as we move into construction, that third one area that McKinsey suggested people were focusing their effort on was on construction automation or on-site execution. And I think it was Stefan who mentioned briefly our relationship with Topcon, our strategic partnership with Topcon, and I know we're going to be joined by a colleague from Topcon this afternoon, so I won't dwell on this area very much. But what we're able to do through our CDE and through Topcon's Magna Enterprise is actually take the 3D models directly into the field and onto the machinery that's used to construct these assets. And not just theoretically, but in reality, actually collect information as we're constructing and then take that full circle back into our design environment to be able to look at the as constructed model versus the as design model and see whether there's a difference between the two and keep that as an accurate record. But more on that later. Because as we move into operations again, here we have our existing roadway and we're just changing the date and taking information out of our CDE to update the interchange in that particular area. And that is our state moving forward. That's our roadway network that is now managed as that upgraded interchange. So we've gone full circle, if you like. So let's talk about railways. It won't have escaped your attention, even if you don't work in the rail world, just how complex rail and transit is. I think it has everything. It has civils, it has tunnels, it has structural, it has power, communications, everything. And in the case of an underground railway and a metro, everything is really compressed into a very tight area, 3D area. And this is just a section through in one of the Crossrail stations that Ian is going to be talking about a little bit later in the day. And you'll see that all of the different disciplines that are involved in not just designing and constructing the asset, but also maintaining the asset that's got to be done safely and effectively while you've got people moving through the system and across your rail network. So hugely complex, huge number of moving parts and people involved in their design, construction and operation. And in rail, Bentley chose to take note of other industries. There are other complex industries out there, things like defense or aeronautics or space, or even some areas of manufacturing that are using something called systems engineering, even in software development, systems engineering. And put simply, it's a way of getting your ideas and your requirements all the way through preliminary design, specification, detailed design, construction, and then through testing and commissioning to hand over, so that at every step of that journey, you ensure that what you wanted is what you're getting. And they use what we call a V diagram. Systems engineers use a V diagram. And this is just a simplified way of looking at how to go from your initial ideas through to the asset that you're operating and maintaining in the future. And I'm going to use that methodology, use that V diagram that you see at the top of the screen there as my way of taking you through our rail solution, which is called Open Rail. In the same way as road is founded upon that CDE, so is rail. So we have an open rail connected data environment that goes across the whole life cycle through project delivery and onwards into operations and maintenance. And it, as the slide says there, connects everything. It connects all of the data, it connects all of the people that are involved in the project, all of the different disciplines that are involved in the project or asset that is in an operational state, and brings them all together and allows them to work more effectively together. And again, I'm going to start in an operational environment, because using Open Rail operational analytics, which is part of our AssetWise family, we can actually look at the existing condition of our railway and how it's degrading and how it's being maintained, and the geometry information that is existing there to be able to make better decisions on our design projects, on future projects. So in this example here, we're actually looking at running some analytics on the existing geometry and condition and working out whether we can increase the line speed. So can we reuse this piece of track between A and B at a higher speed? And by clicking on the red area here, it says, no, according to the criteria that you've set for your analytics, the transitions are too short at that point. There will be lengths in green, perhaps, that you can reuse, and then using that decision, that analysis, to be able to set decisions and set requirements as you move through and start up a new project. Mirroring roads, we have Open Rail Concept Station. And I wanted to show this because it goes into a little bit more detail than the road example I gave you earlier. So it allows you to bring that contextual information in, reality meshes or survey data or aerial mapping, whatever you need to provide context to the design work that you're producing at the time. And then start to explore your different design options. So sketch out your design. Where's the new railway going to go? Where are the key points on the design? And interactively changing that design so that you can refine it. In the case here, we've got a new railway that we're going to put down the middle of a street. Now, railways tend to be connected by stations. So you might want to bring in a station model that's been designed in Bentley software or another piece of software. So here in 3 dimensions, we can import and reference in our station design and then adjust the 3D geometry of our track to match that. You see you've got a profile alongside your perspective view there now. Now, those of you who are sort of keeping up with the way that it's moving through will recognize that we've actually got earthworks in the area of the station, which is no good. So we might want to change it to a bridge. You can change the asset types however you want to. You can adjust the design in many different ways. You can model the existing infrastructure, because you're going to need the required clearance between your new track and your existing roadway. So very easily we can say we need 12 meters clearance between the new railway and the roadway. When it's red, no good. Lift the geometry of our railway, turns green, we know we're good as far as clearance. So it's very visual, very interactive. We can move the different components and tweak the design as and when we wish. Now, we can also start to add other assets, both linear and isolated or individual instances of assets. So here we're adding the overhead line, purely in a conceptual and layout way, but we can model the masts, we can model the catenary and the wires, we can change the types and reassign those. And I mentioned that relationship that we have with Siemens, and we're working with them to link their CCAT master overhead line design system, detailed design system, with our own open rail solution. And earlier this week I was in Berlin at Intertrans, and Bentley and Siemens were previewing that software on their booth there. But we can also place barriers, signals, and again, get costings out at any point in time so that you can understand, and here's the example of that. You can get a full report, you can take that out to Excel or pass it to your own costing solution as well, and then finish up creating some really quite visual designs. So, moving on. We're finding that more and more of the Bentley users I speak to, are being asked to go further and further into the design work to actually win the job than they did before. And a lot of the time that you spend on conceptual design, if you don't win the job, is wasted. But even if you're lucky enough to win that contract, then you've got to almost start again. Well, with Open Rail, we're removing that step. You can take all of the designs that were created in Concept Station all the way through into detailed design and reuse that design work, reuse that engineering information to actually add the detail that's required for later on in the project. The product that we do that with is Open Rail Designer. So here's another short video of Open Rail Designer, which was launched earlier this year. So here we're actually looking at existing surveyed information and working out where our straights, our transitions, and our arcs are. We're using what we call regression analysis to be able to extract the geometry very quickly, very easily, to be able to build your track or your centerline alignment. And you'll see it's over some aerial mapping there, and we can extract all of the geometry information, coordinates and straights and radiuses. We can place turnouts to lots of different international standards and different classes of rail and transit, be it high-speed rail to street rail, trams, or indeed metros. It's very interactive again, but at a detailed stage where we've placed a left-hand turnout. We're going to link these two pieces of parallel track. It does all of the connections for you and trims the track very quickly and easily and makes sure it's to the right level of accuracy that you need. In 3D, so we can apply cant or super elevation to our design, or as we see here, design sidings or marshalling yards very quickly and easily in 3D and start the corridor modeling of our railway as well. Where are we going next? Yes. So if your design changes at any point in time, it can be quite a task to actually rework or re-engineer as a result of those changes. We call the modeling of design intent the ability to actually recover more quickly from those changes. So we can relate different parts of the design and rules to how they behave. So if an alignment moves, either in 2D or 3D, those design changes can ripple through. And you see another example of that here, where we're taking out an earthwork strategy on the right-hand side there and just changing it for one with a ditch. And if you watch very carefully after we click OK in the top right here, you'll actually see the design change in an instant. And with that, not just your design, but all of the drawings, your plans, your profiles and sections that have been created as a result of that. So those design changes ripple through all of the rest of the workflow and onwards into construction. Now, no railway would be complete without some stations. So our station solution, which will be available soon, is actually an extension to a very an existing Bentley product called EcoStim Building Designer. And we're busy working to tune Building Designer to the rail and transit environment by adding additional functionality. But in its current form, it allows you to bring all of the different disciplines together. So here we can see our station model alongside the bridges and the track and the overhead line. We've got a reality model in the background, adding further context to our design work. But Building Designer and Station Designer allow you to model buildings of all types, sizes, or complexity. You can model them and analyze and also visualize everything to do with that building, including, and as we'll see in a moment, construction sequencing and simulation within our EcoSim Station Designer product, which will be available soon. That's pretty unique to Bentley's open rail solution. Those competitors that we have in this area can bring the information together, but it requires exporting the data and importing into different packages and environments. And of course, every time you transfer information, you export information, you risk devaluing it, you risk losing information. So being able to model everything in that same modeling environment, that comprehensive modeling environment, is a very valuable differentiator between open rail and its competitors. And you see here just some very simple sequencing and simulation. I will just mention the acquisition that Stefan spoke of earlier in the morning, that of Synchro. And we will obviously be integrating Synchro and its capabilities, which are very well respected globally. And a lot of their business is actually focused in the rail area into our open rail solution in due course. I won't spend too much time on BIM review. Stefan has already spoken about it. And we've got a rather extreme example here where we've got an overhead line structure actually poking through our roof structure there. But really it's about bringing all of that information together to spot things like that whilst it's still in the design office and not whilst you've got people and machinery waiting around costing money. It's about optimizing both the design and the construction schedule as a result of using technology like open rail. Really, it's about getting it right first time, using technology to help you do what you do best, better, and get it right first time, every time. Because ultimately, we want to hand over a safe, compliant asset to the owner so that they have a good base upon which to maintain the asset into the future. Now, straight after the break, Ian Miskamin is going to be talking to you about Crossrail. How many people have heard of Crossrail? Quick show of hands. So maybe just under half. Crossrail is a new east-west rail link across, or actually under, the city of London, up to about a depth of 30 meters below the surface. And if you can imagine the underground network under London and all of the buildings and their foundations, that's quite a complex 3D challenge, as well as, because of the scale, technical challenge and contractual challenge. It's using public money, so the media is very much focused on its success. It's had a set deadline for completion, which, while that has in the last few weeks been reported as slipping, actually there was a really good article in the Financial Times last week that spoke about it. The success of Crossrail is in the engineering, I won't say perfection, but the engineering value created throughout the project. And actually, while it did or has gone over time and over budget by a little way, if you compare it to the majority of other major rail projects around the world over the last 15 to 20 years, it's an insignificant overrun in relation to the rest. Very complex, huge supply chain. At the height of the detailed design, pretty much every design consultant in the UK was working on Crossrail in some way, shape or form. Lots of standards that they needed to adhere to, and they had quite a clear vision. And their vision, and if you think back to some of my starting slides when I started to talk about the CDE, we had the project delivery twin and the asset performance twin. They talk about delivering two railways. The physical railway that they are nearing completion and are already running trains down as part of the commissioning process, but a digital twin, a digital version of that railway that is an exact replica that will be used as the basis for their ongoing maintenance of that railway into the future. And straight after the break, I think it is, Ian Miskimin is going to talk to you in more detail about how they've been successful, and the academy, the Advancement Academy that was opened in London, is a real significant part of that. So to finish, we're dropped back into operations and maintenance, because here we've got an existing railway. We've sent a track recording vehicle down it, and we can look at how the track is degrading, how we're maintaining it, and start looking at trending of information. I mentioned big data and sensors in the infrastructure. Here, we're looking at some reports from a point, a switch. And we're seeing actually down here that the time it takes to open the switch has increased dramatically, and the power that it's using has gone way, way up, higher than it should be. So we're getting real-time information about that asset and helping us give insight to be able to improve the decisions that we're making while we maintain it. And this links through, it looks at failure modes, it helps the inspector or the maintainer identify the right solution to be able to then send it out to the crews in the field to go and maintain it, but also achieve the compliance to all of the different standards that are applied in an operational environment. Ultimately, it's about, whether it's design, construction or operations, road, rail, or any type of infrastructure, our software and services are targeted at helping you change outcomes, improve outcomes for the future. So in road and rail, we do that with our CDE, which connects all of the different stakeholders, disciplines, data and applications, and helps them work better to be able to streamline project delivery and increase asset performance. And in roads, it's housed around that Open Roads family of products, and in rail, perhaps no surprise, around Open Rail. And with that, I will say thank you for your attention. I hope that's been interesting and valuable. I'm here for the rest of the day. I'm more than happy to talk to you on a one-on-one basis or make contact and talk more. But for now, thanks again for your time.